What's up everybody? Let us deploy a Spring Boot cloud application for free. So as you can see, I have already opened up my project within IntelliJ IDEA, and it is just a simple cloud project. And if I open up the user controller, you can see that I have a couple of APIs. For example, the one for saving new user, another one for getting all the users, and so on. So let us deploy this project and test it once we have successfully deployed it. In order to deploy our project, we just need to have a remote database, and for that we are going to use Neon. So basically, Neon offers a Postgres database, and within their free plan, you get up to 0.5 gigabyte of the storage, and you can create up to 10 database projects. So just head to console.neon.tech, and if you don't have an account, you would just sign up. It's just a simple process, and if you already have an account, you will log in to your account, and after doing that, you will be redirected to this dashboard page. So now let's go ahead and create our new database project. So let's hit on new project button, and here we just need to provide our database project name. So let's call it, for example, Spring Boot Cloud. Spring Boot Cloud, just like that. And the database name, let's call it Cloud, and you can choose whatever provider that you like. So I will leave it as it is, and just make sure that you choose a region which is closest to you. So I am going to keep using this US East 2. Let's just click on this create button. Nice, our database project has been created. And let me go back to IntelliJ IDEA, and if I open up the application.properties file, you can see I am using MySQL database. So now it's time to switch from MySQL database to a Postgres database. So first of all, let me comment out this line and uncomment this one. And since we are going to use Postgres, we just need to add it to our pom.xml file as a dependency. So down here, let me paste in our Postgres dependency and save the file. And once you add a dependency to your pom.xml file, just make sure to click on this Maven icon and sync your project. Nice, our project has been synced and all the dependencies has been downloaded. So let's just click on this Maven icon just to hide that sidebar. And if I go back to our pom.xml, our application.properties file, here we just need to change the data source driver class name. Instead of MySQL, it is going to be org.postgresql.driver. And next, we just need to provide the database connection values, the URL, the username, and the password. So for the best practices, I am going to create a .env file so that I can store all those values inside that file. So here on my project load folder, I will do right click here and choose new, and then choose file, and then the file name must be .env, and hit enter. No, I don't want to add this to Git because basically you don't need to you don't need to push .env file to your GitHub repo. So let's just go ahead and provide all required environment variables for our Spring Boot Cloud application. Okay, the first environment variable that we need is our application's port. So let's give it 8080, and for the database URL, let's go back to our Neon console dashboard and click on this connect button, and here on this connection string, click on it and choose parameters only. So the first thing that we need is to grab our Postgres database host. So let me copy this one and go back to IntelliJ IDEA and paste it here. I just need to provide the host here. Basically, the connection, the database URL must start with jdbc postgresql / your database host. This is the default Postgres port, and here you just need to provide your database name. So our database name here is Cloud, so I'll copy this one and go back to IntelliJ and just replace this and leave everything as it is. So this is the structure of our database URL. So the host, the port, the database name. That is all you need to provide. Okay, so let's go ahead and provide our database username. So the database username is this one. I will copy it and go back to IntelliJ, paste it here, and let's also copy the password. Okay, so if your password is hidden like this, you just need to click on this show password button, and let's copy the password and paste it here as well. Now let's save the file, and for our application to recognize all the environment variables that we have specified within this .env file, we just need to click on these three vertical dots and click on edit, and then make sure that this .env file is enabled. So if it is not enabled, just click on it, and here oops, I had the env file, but if you don't have it, just click on this. For example, let me remove it just to show you what you need to do. So basically you will find this list as empty, so just click on this plus button and then choose .env file, and go ahead and choose the .env file that you have created. So you can see this .env is under our Spring Boot RESTful API, and so I am going to choose it here. You can see our .env. This is the file that we have selected, and let's click on apply button. And if you want, you can go ahead and run your project directory, but for now let's close this one. We just need to reference all these environment variables within our application.properties. So for the database URL, let's for our data source URL, let's remove this one and do $ curly braces, and let me go back to the env file and copy the environment variable name, paste it here. For the root, we do, for the username, sorry, we do, let me go back here, copy this one, back here, paste. Let's also provide the database. We do a $, and let's go back to our .env, copy the DB password and paste it here as well. Just make sure that all these values match with the ones that you have provided here within your .env file. And lastly, let's also provide our application port. So we do that by saying server.port and echo colon curly braces, and let's paste in the value that we have specified, the variable name that we have specified within our .env file. Nice, that is done. Let's save the file. And also, if I go back to our database, let me close this one, and here you can see we have tables tab. Let me click on this one and just give it a second to load. You can see our database, we have 0 tables in our public schema. So let's try to run our application just to see if everything is working fine. So if everything is working as expected, we should see some tables get created automatically within our database. So let me hit on this run button and just wait to see if everything works as expected. Okay, our application has started. Let's go back to our database project and click on this refresh schema button. Interesting. So still 0 table in our public schema. So we might be doing something wrong. Let me double check. So we have the DB URL, DB username, we have the password here, and yeah, so let me check our .env file. So everything, yeah, that should be fine. Let me stop our application. And okay guys, so this is the error. So we have done everything correctly, but within our user table, Postgres doesn't like this name. So let me go back to our models, and here within our user model, let's provide a different different table name. So let's annotate our class with at table, sorry, T capital, and let's provide the name instead of using user, because user is a special name to Postgres, so I will call it users with S. And let's save the file and restart, stop our application, stop it and start it again. Okay, so our application has started, and there is no error within our logs. So hopefully our users table should be created within our database. So let's hit on this refresh button, and yeah, you can see our users table has been created automatically, which means that now we have successfully connected to our remote database. So let's go ahead and deploy our application. So I will stop the project, click on this one, and for us to be able to deploy our project, we just need to have Docker installed within our local machine. And if you don't know how to install Docker, I will leave a link in the description for where you can go ahead and download the Docker and install it into your computer, regardless of the platform that you are using. You also need to have a Docker Hub account. So if you don't have a Docker Hub account, please just go to hub.docker.com, and once you reach to this platform, you will create an account here, and once you log into your account, you will be taken to this dashboard where you can see all your repositories. Okay, so back to our IntelliJ idea. First of all, let's create a Docker file within our root directory. So here on my project root directory, I will do right click here and choose new file, and the file name must be Docker with the capital Docker file, just like this. And yes, I want to add this to Git, and let me go ahead and paste in everything that we need for our Docker file. Here I have created this project by using Maven, and I am grabbing Maven latest image, and we are copying pom.xml file and execute this command, and also we are grabbing OpenJDK version 21, but you have to make sure that this version matches with the one within the pom.xml file. So let me double check on that. So you can see I am using Java version 17, so it is a good practice to use the same version as the one that you have used to create your project. So next here, when we are building, we just need to provide to specify the final name of our jar file within this pom.xml file. So under here within our build section, let's just provide the final name for our jar file. So you can call it whatever you want. Let's call it Spring Boot CRUD, just like this. So the purpose of doing that, if you don't specify this name, whenever you build your application, the final jar name is going to be a random name, and we just need to specify that name here. So there is no way we are going to know what random name Spring Boot is going to assign to our final jar file. So it is a good practice just to provide your final jar name. So let me copy this one and go back to our Docker file. So let's update this one with a correct name. So we have called it Spring Boot CRUD, and let's update it here as well, and here as well. Okay, so let's save the file, and one more thing that we need to do is to create a .docker ignore file. So let me do right click here and choose new file. So the file name must be docker ignore and hit enter. Enter. So yeah, I want to add this to Git. Basically within this docker ignore file, we just specify all the files that we don't want to include within our Docker image. So the file that we don't want to include into our Docker image is this .env file. So let's just specify the file .env and save the file. And after doing that, we are just going to build our Docker image. So let me clear the terminal and let's do Docker. And by the way, for this step to work, you must have a Docker Hub desktop installed into your local machine, and you must learn it for this command to work. So the command for building our Docker image is docker space build, and we just need to provide the tag name for our Docker file. So let's do -t, and here you just need to specify the tag of your Docker image. So if I go back to Chrome, and here within my Docker Hub, you can see my username is this one. So I always like to name to tag my Docker image by starting with my username, just like this, and then / you can just provide whatever name that you want. Let's call it Spring Boot Cloud Project, and also let's give it a latest tag. Let's call it latest, just like this. Next, we just need to leave a space and add a dot, just to say that our Docker file resides within this path. And let's hit enter and wait for our Docker image to be built. Nice, our Docker image has been built. So now let's push it to our Docker Hub. So let's type docker push, and we have to repeat the same tag that we have written when building our Docker image. So we'll copy it and paste it here, and let's hit enter. And if you are not logged into your Docker Hub account, here the terminal will prompt you to log into your account. But for me, because I have already logged into my Docker Hub desktop, that is why it didn't ask me to log in again. So let's wait for the process to finish, and I'll be back once it is done. Okay, nice. Our Docker image has been pushed to our Docker Hub, and if I go back to Chrome and refresh this page, let's give it a second to refresh. You can see our Docker image has been pushed to our Docker Hub account. Okay, now it is time to deploy our Docker image. So let's head to render.com. I will open up a new tab and hit enter. And basically, Render will allow us to deploy our Docker image for free. So if you have an account, just go ahead and log into your account. If you don't have an account, just go ahead and create an account here on Render. And once you have created your account, just go to your dashboard by clicking on this link. And okay, let's close this, and here you just need to click on this new button, and then choose web service, and here for the source code just choose the existing image and go back to your Docker Hub account. And here let's click on tags tab, and here I will copy this one, and let's go back to render dashboard and just paste in what we have copied. And you can see render has successfully detected our our Docker image. And if your Docker image is private, you will be asked to provide your Docker Hub account credentials. So I will click on connect and give your project a name. So let me remove this and leave it as it is. And here you just choose a region which is closest to you, and let's choose a free plan. And down here we just need to provide all required environment variables for our application. You can see I have port environment variable within our .env file. We don't need to provide our application's port within our render dashboard because render will take care of that and assign a dynamic port to our application. So we just don't need to provide a port environment variable within our project that we are going to deploy here on render. So after providing all required environment variables except the port, just click on this deploy web service button and wait for your service to be deployed. Okay, nice. You can see that our service is now live. So now let's go ahead and test our application. And also one more thing that I forgot to mention is that since we are using a free account, Render will spin down our application anytime we are not using it. So, and the next time we start using our application, there will be a delay which is almost 1 minute, and this is just because this is a free plan. But after that 1 minute of delay, your application will work as normal. And if you are not happy with this, you can just go ahead and upgrade from a free plan to a different plan. But for our use case, this is just enough for us to be able to test our Spring Boot application online. So let's right now copy this URL and start testing if we can be able to add the users and just do some CRUD stuffs to our deployed Spring Boot project. Okay, now I am within Insomnia. If you want, you can use Postman, whatever tool that you want. And let's paste in our application URL and then / let's go back to IntelliJ just to check how the URLs are structured. So post API / user. Okay, so let's try the API for adding new user, API / user, and let's make it this a post request. And here within the body, we just need to provide our user object. So, oops. JSON, let's paste it here, and yes, comma, and hit send. And yeah, because we are accessing our application for the first time, it is going to take almost 1 minute, but after Linda has restarted or rebooted our application, the next requests will be much faster than this first request. So if you are not happy with this one, just go ahead and upgrade to a paid version. Okay, timeout was reached. Let me send the request once more again. HTTP render. Okay, nice. You can see our user has been created. He has been given the first ID, and if I go back to our Neon database, let's just refresh this table and click here and give it a second. Let's do, oops, you can see this is our user, and let's try again to add one more user to make sure that everything works as expected. James, let's send the request. You can see now the request was much faster than the previous one, and you can see our user has been created as well. And if we go back to our Neon database and click on this refresh icon, you can see our second user has been registered as well. Let's try to test the API for getting all the users. So it is a get request, yes, and let's send this request, and you can see we got back the 2 users that we have registered. Okay, that is all that I wanted to share. If you have enjoyed the video, please hit that like button, and also please consider subscribing to my YouTube channel, and I will see you in the next one. Bye.